Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be getting back to some of the roots of this channel, which is crazy DAX. And comes to us by way of Tamer Juma, one of my favorite DAX guys out there. And normally he's the one solving these kinds of challenges. Like he's bailed out no calculate approach like the last two Alexis Olsen attempts. But anyway, but he came up with this really rather interesting scenario, which is a real world scenario. And just again, star schemas and calculator not the solution to everything, right? Here's a perfect example of that. So basically, what he has is he has a central monitoring systems or building management systems. A lot of times they will generate data in this way, which is really nice for Excel, for analyzing in Excel, where basically what's going on here is that you're recording temperatures for every 10 minutes of the day, and each 10-minute increment of the day it gets a new column in the table. So you have your sensor, your date, and then for that sensor on that date, you have a full day's worth of data for every 10 minutes increments. All right. So obviously, the first thing you're going to say is, well, you should need to unpivot these columns. Like select in Power Query, select these two, right click, unpivot other columns. Then you'd have a nice attribute and a value column, right? And then you could just average your because you want the average. He wants the average daily temperature against the date axis. But he also puts a stipulation here of it's got to be a live connection, which pretty much rules out Power Query and doing anything like that. So basically, this means we need to solve this in DAX. Is what I kind of took this challenge as. And the interesting thing here is he's got a single select slicer, which means that at the end of the day, if we can filter that for each point on this line chart, there should only be a single row of data, right? Because if you selected a single sensor and you have a single row of data because you have one row for each date. Okay, so I'll skip past that. Where's my first one that I got into? If I can find it. That's the final version. Here's the version. Okay. So first of things that this looks like what I've created in the past, which is multi-column aggregations or a DAX unpivot. Now this works okay, but maybe not for 144 columns, right? So if you're not familiar with these functions, they both work basically the same way, where you have multiple values, right? And you want to aggregate across multiple columns of data. So the standard approach, right, is you select your columns of data, you union them together, and then you run an X aggregator across it, right? And DAX unpivot is basically the same way, where essentially it's the same type of a process where we're unpivoting these columns, but we want to keep these two columns. So it's more like a DAX unpivot kind of scenario. But again, it's the same process where you're selecting your columns, you're union them together. I think we filter out like where it doesn't equal, null essentially, to get rid of any of these kind of columns. And then, basically this would be a table. We could virtualize this in a variable, obviously, and then run an X aggregator across it. Same type of process, right? But generating the code for that, for the DAX code, would be miserable, right? Because you basically have to do 144 lines of this, where you're selecting the each individual column every time. I mean, maybe you could have ChatGPT write that code for you. We don't really have anything like in Power Query where we can select two columns and say remove other columns or keep other columns or anything like that. Where we could like start at the first one, hold down Shift and select the last one, and then remove other columns. We don't really have that ability in DAX, in terms of unpivoting that and having like Power Query Editor would write that code for you. So, there's got to be a better way, right? So here's let's bring up the Power BI file. So here is the data file, right? This is in import mode, obviously, but we're going to simulate like this has to be live data, and we can't do anything in Power Pivot or Power Editor. Power Query editor. So how do we deal with, multi-column aggregation across, this huge number of columns that we have? Well, so first attempt, and I'll get in here, and we'll go over here, and I will be sure to zoom in on code, because sometimes I forget. All right, so first attempt at this was essentially what we're doing in the first line, the text variable, is we are abusing two CSV and path items in this solution, and that's going to be a common theme throughout this. So what we do is we take and we to CSV our T measures table, so our table of data, and we're grabbing we want to grab all the rows essentially. And maybe, I would need to, there might be need some tweaks in here. If I can, hang on a second, let's try this again. Like I might have to specify a maximum number of rows with 144 to make sure it doesn't bring back just 10 rows, things like that, because I think it defaults to 10 or something like that. But those are minor tweaks that we could make, right, to make sure that this works correctly. So essentially we to CSV the table, which this may seem kind of weird, but then what we can do is then we can replace all the commas with pipe characters, which turns it into a path. Okay, then we can, at that point, we essentially can use the text to table trick, right? Or if you want, it's the mythical DAX index, right? So what we're doing is we're generating a series. In this case, we have two pre-columns, right, that we want to get rid of, and because we just want the data columns. So we have to go from 3 to 146, because the data starts in column 3, and then column 146 is the last column of data. And essentially, we are incrementing by 1. We then can use the path item to pluck, each of the values out of our text string. So now we have a column. Now we have a table of data that essentially has been unpivoted in kind of a sort of a neat way, I guess you could say, without having to write a bunch of code. We can then do our average X across it, right? So this is a fairly simple, and we're going to see this concept evolve over time. Now the problems with this that Tamer Juma pointed out was like, well, what happens if I add an additional pre-column, or that sort of thing, and then this is going to break, and I have to change the code. Now I have to go, if I add an additional column, I have to go from 4 to 147, right? Is there any solution that I could get to that would allow me to not have to change the code and have it always work? And the answer is, yeah, there's some ways around this, right? So the other thing, so the sensor 5, right? So you can see these things change over time. It's pretty quick once the first time that you load it. Well, but it does take 4 or 5 seconds, like the first, it really has to go out and grab the data and stuff like that. So, but after that, it's super quick. So not the quickest measure in the world by any means. It's probably to be expected to a certain degree. All right, so, but, one of the things I noticed about this, as well as after Tamer came back with his feedback, is that the interesting thing is if I change this to a table, it doesn't load the visual, right? And so it's not the most robust solution. Calculation error cannot convert value 63 sensor 2 of type text to type R. So something's going haywire in the code that's causing this to break essentially. But for some reason, it does not. It breaks in a table, but not in a line chart of all things. Okay, so taking Tamer's feedback and this kind of problem into consideration, decided to come up with some alternate solutions. So measure 2. So this one abuses the path the path functions to an even greater extent. Right. So we start out with the same concept, right? But this time we include the header. Okay. So the to CSV, that one that's sitting at the end, the last parameter says include the header, don't not include the header, which is what we were doing in the last version of this. And then what I'm doing is I'm replacing unicar 10 with the pipe character. Okay, so which means that I'm going to have a path essentially where the first line contains my headers and my second line contains my data. All right, so now what I can do with the path item, I can grab text 1 and then I can for 2. So I grab my path item. So the _1 holds the headers, the _2 holds the data. All right, so now what I can do is in 2, I can substitute the commas with the pipe character to turn that into a big path. But what I'm doing here is I'm only substituting the second comma with the pipe character. So now what I have is I have my header columns, my pre-columns, right, are in the first part of the path, and my data is sitting in the second part of the path. I can then, in underscore 4, I can grab just the data columns, right? Because, I've separated that out via path. Then in my path variable, I can then substitute the commas in there with the pipe character, turning it into a path. And then I can do the same thing, right? I can add the columns 1 to 144, because now, right, I have, I've eliminated that whole where I have to calculate like, 3 to 147 or 4 to 148 or whatever it is. Right now, I know that it's always going to be 1 to 144, and then I can do the same thing, and it actually then works a little better. Like, for example, this is my first attempt to do this. So, for example, if I convert this to a table, and we give it a few seconds here, again, it's not super speedy. There we go. So it actually works as a table as well as a line chart, right? Again, it's the same situation where you can switch between sensors and everything else. Now, the downside to this approach, in this particular case, in this particular measure, is that I'm pretty much reliant on I can only have one row of data for each thing that I'm processing, right? So if I get into a situation where I wanted to analyze the average temperature between all the sensors at the same time, then this would fall down and not be able to do that. It would call, it would not do that. Let's put it that way. Okay, so measure 3, and again, throughout this whole thing, what I was trying to figure out was how can I remove columns in a table, right? We have a select columns function in DAX, but we don't have a remove columns function in DAX, which would be really handy in this situation, because if we had that, it would make all of this kind of a lot easier and go away. Okay, so another thing that I took a look at is something that can actually remove columns is substitute with index, sort of. Now, substitute with index, even though the documentation reads as if, well, I can have 2 columns or 3 columns that are in common between 2 different tables, and then I can do a left kind of a semi-join on these things, and I would reduce all of those columns down to one index column. Doesn't really work out that way practically. So when I tried to do this, and I tried to have sensor tag and dates all in one column by just selecting those columns as a table, substitute with index failed miserably. It didn't know what to do. It seems like it needs to have distinct values within the second table that you specify. So what I do is I grab my distinct sensors, I grab my distinct dates, right? I do a substitute with index where my table, right, which is just the T measures table, I tell it, hey, I want my index column to be index. I feed it my sensors, and I say sort on the sensor tag, index by sensor tag, ascending, and it basically brings back a table with an index column on the end, and my sensors column is gone. And I'll show this in a table version here in a second. I do the same thing with the dates table with index 1. Then I can do my exact same thing where I substitute 2 CSV. I don't include the headers, type character, turn it into a path, 1 through 44, right? And this one works very similarly. It's actually rather faster than the measure 2. And if you want to see what this the internal workings of this, so this is where this was my debugging, where I created a table with it. So if you see here, table T measure is the same code. It's just I'm not going through the step to actually aggregate the data together. And you'll see at the end here, this is where my index and my index 1 end up, which is kind of nice. It means I'm shifting those columns from the front to the back. So now I can always have 1 through 44. 1 through 144 are all my data columns, right? Okay, so that was that one. Still wasn't quite happy with it in terms of it still had to modify code in order to get this thing to work if you add pre-columns. So is there anything we can do about that? Well, turns out, yes, there is. It's we add some more additional complexity in code. So, so what I do in this one is I do this. I start the same way as measure 2. So I substitute 2CSV, include the headers. I turn the whole thing into a path where I have the first part of the path. Path item 1 is my headers. Path item 2 is my data. I can grab my path item, underscore 1 is path item, underscore text, grab the first path item, which is my headers. I can then find my first colon. Okay. So I find the first colon within it, which should be my data columns that I want. So skipping past all the pre stuff, I'll find the location of my colon character. I can then use left function to grab everything to the left of that colon. And then what I can do is I can figure out how many columns of data are in there by essentially doing a little trick where you substitute the commas with blank, with nothing, null, basically. And so you subtract the length of the string from the length of the string where you substituted all the commas with nothing. And that gives you how many commas are in the code, or in that text string, which in our case represents how many columns there are. Okay, so then I can grab my data, path item 2, and I can substitute the pipe character, but at the location of my comma. So essentially, if commas comes back 2, I'm substituting the second comma with a pipe character. If it comes back 3, I substitute the third comma with a pipe character. And so now what I've done is I have, again, kind of dynamically figured out how many columns I have instead of hard coding it into like a 2 or a 3 or whatever it happens to be. So again, it's the same code as measure 2. At that point, I can do a path item of underscore under 3. The second part, grab all the data stuff. That's after that last comma that we've, figured out dynamically. Do a substitute, turn it into a path, go through, generate the series, the table, do an average X across it. Again, this is the one that Tamer accepted as a solution, because essentially, if you add pre-columns to this, then you won't have to worry about you don't have to worry about anything in terms of this code will figure it out dynamically. But I wasn't satisfied quite yet. I wanted to be able to, wow, this is great, but this is, again, it's single row of data that I'm dealing with. Is there a way to do the same thing and not have to hard code, like, for example, the 144 in there? What if there's, maybe they switch their monitoring to every 5 minutes, so now there's 288, and what if you want to analyze all the sensors together? So could we come up with a version of this which would allow for multiple rows to be analyzed at the same time and be even more dynamic in terms of being able to figure out, and not have to change things? Okay, so that resulted in measure 5. So this one I've actually annotated because it's a little crazy. All right, so the first thing I do is I deal with my headers. So in this case, I grab my 2CSV T measures, I include my headers, and I do the unicar 10, replacing the line feed character with my pipe. So that now that path item 1 is my headers. So again, I do a path item, I grab the headers. I do the same thing where I find the colon, right? I do a left, I figure out how many commas there are, right? It's the same code as before. Now to deal with the data, I do something a little bit different, right? So again, I substitute, I do a 2CSV of the T measures. I don't include the headers. That's the 0 at the end of the 2CSV function. I do a substitute where I substitute the line feed characters with the pipe. So now I have a path where every row of data is a path item, right? I can do a count rows on my T measures, right? So in context, how many rows do I have? So then I can generate a series between 1 and count, increments of 1. And here I actually embed the code previously where, I'm stripping out those pre-columns, right? So for each of those path items, so let's say there's 3 rows of data, right? For each one of those, I'm adding a column called underscore data, where I take the path item of the table without the headers and the value, which is basically I'm turning that text string into a table. I substitute the text at the calculated comma location, right? So if there's 3 columns of data that are prefixing the data, or 4 or 5, that's been figured out dynamically. And I put my pipe character there, and then I can return the second item, which is all of my data columns, and filtering out my pre-columns, if you will, and return the result, right? So now I have a table called __ data that has, all of the data that I want in it. So now what I can do is I can concatenate X that data table up, right, and put in the pipe characters, put the pipe characters back in. So now I've converted that table back into a text string where each row is a path item again. Kind of crazy. That's kind of where we started. Now we're back to it. Now what I can do though is I can substitute my data text, comma with the pipe characters to convert all of those commas into. So if I have 3 rows, I'm going to have 144 times 3, right? And I can now create a path item for each one of those columns, right? That's the __ path variable, right? And then I can figure out how many data columns I have by doing the same trick where I substitute the commas with, that are in data text. I can substitute them with nothing, right? And I can figure out how many columns of data we have, right? So now I don't have to hard code my data columns. Now I can generate a series between 1 and data columns, and then add in my path, grab my path value out of my __ path variable, and then the +0 is there just to make sure it comes back as a number, so I can average X across it. So this one actually, so you went from something very simple like that to you had some intermediate steps to this monstrosity. All right, so but the nice thing about this one is that I can actually, if I uncheck that and we wait for the little spinning icon here to come back, and yes, it does take a few seconds. So I'm sure this can be optimized, right? First step in every solution is get something that works, and then you can worry about optimizing it later. And this one does take some time. All right, there we go. So now we have a version of this that has all of, that we're actually averaging across all of these sensors on each date. So for every day, we actually have 1, 2, 3, 4. We have six rows of data, right? So there you have it. Kind of crazy, but it does work, right? And so it works at the individual level. And when you go into here, in terms of, it works at the individual sensor level as well as the overall level. Or you can even pick like sensors 3 and 4. And it'll work across 3 and 4. There we go. So now we have an average across 3 and 4. So 3, and check 3. So 3 is around the 50 range, 4 is around the 140 range. So it makes sense that, yes, the average between those would be around in the 90 range, which is exactly what we see here once this thing comes back. There we go. So anyway, crazy DAX, right? And I'm thinking of putting this out into the quick measure gallery at some point, but I probably need a better name for it than multi-column aggregations on steroids. So any suggestions you guys have that you guys want to put in the comments of this video as far as what to call this thing, happy to do it. If you have a better way of doing it, I'd love to see it. But I really like this challenge because, again, star schema and calculate's not the end all be of DAX people. There are real world problems where those just don't apply. And if you trap yourself into thinking and calculate always, then you're not going to be able to solve those kind of problems. So there you have it. Hope you enjoyed the video, and I'll talk to you next time.